In an arithmetic sequence, we find the next term by adding or subtracting a fixed number to the previous term. And this is exactly what we've seen in our example here. Right. Okay, so the first term is 3, the second term is 6, the third term is 9. Well, what happens between the terms here is that we add 3, right? So this will continue as a arithmetic sequence, because every time we get a new term, we add the number 3. Now, this fixed number is called D, or the common difference. And again, we label the terms with an index. So the first term is U1, second term is U2, third term is U3, fourth term is U4. Now, any given term can be written as UN, where n is the index or the identifier for the term. So this term will be the nth term. We could look at some examples. So, for example, if I write the sequence 1, 2, 3, 4, 5, 6, and so on, the first term is 1, and the common difference is also 1. So, and this happens to be the sequence that we also label n, or natural numbers. If we have the sequence 2, 4, 6, 8, 10, 12, and the first term U1 is 2, and the common difference is 2. Third example, 3, 2.5, 2, 1.5, 1, 0.5. The first term is 3. And what about the common difference? (0.5), but it descends, so it's minus, yeah. So minus 0.5. So that's the difference between each term, and that's why we call it the common difference. Now, so for these examples, we see that each term may be written as the previous term plus the common difference. And we can see how this becomes systematic as well. If I write U1 like this, then U2 is found by taking u1 plus the common difference. u3, I suppose we could write that as u2 plus the common difference, but I want to write this using the first term. So if I did that, I would have to write u1 plus d. Now this is actually equal to u2, right? And I said over here that u2 plus d is equal to u3. So the third term would have to be u2 plus the common difference. And we can continue with u4 is equal to u1 plus the common difference plus the common difference plus the common difference again. And so a pattern emerges here. We could certainly write u1 plus d, but I choose to write u1 plus 1d now. And for u3, that is the same as u1 plus 2 times d. u4 is u1 plus 3 times d. And to be completely systematic about this, I want to use these indexes to create a rule for creating new terms of the sequence. The problem is for the index 2, the second term, u2, I have a 1 over here. For the third term, I have a 2 over here. For the fourth term, I have a 3 over here. So what I can do then is I can say, okay, the fourth term is going to be u1 plus, well, 3 is 4 minus 1, isn't it? So I could write 4 minus 1, or I could write n minus 1, n being the same as the index that we have at any given time. And I multiply that with the common difference. So, well, let's put in 4 for now, that's fine. 4 minus 1d. u3 would be u1 plus 3 minus 1 times d. u2 would be u1 plus 2 minus 1 times d. And u1 is just going to be u1, of course, but the reason why it's just u1 is because we have 0 multiplied with the common difference. So there is no difference. And we now end up with a general rule for how to find any term in a given sequence. So a formula for finding the nth term would be u1, the first term, and then we add the common difference multiplied with the index number minus 1. So it looks a bit intimidating at first, but it's a formula that makes sense when we build it up like this. So a sequence is a string of terms. U1, U2, U3, etc., all the way up to how many we want. So that's a sequence. We're now going to define a series. So a series is the sum of the terms of a sequence. And we can write that with an S. So the series, and we also give that series, we also give that an index. So the sum of the terms of this sequence, we can summarize as U1 plus U2 plus U3 plus any given terms in between, all the way up to the nth term. So summing up all the terms of the sequence, that gives us the series. So that's the relationship between a sequence and a series. I'll give you one brain teaser towards the end of class today, and I'll give you some time to think about it. Have you heard of Gauss? Gauss, the mathematician, German mathematician from, I don't know, 18-something. But he's been very important for many fields of mathematics, statistics. So there's this story about when he was a boy in school. He had this teacher who was a bit lazy, perhaps, a bit sick of his students. So he would go into the classroom, write a task on the board, and then, go ahead and solve this. I'll be back in 40 minutes. So the task that he gave them on one special day was, okay, you can sum up all the numbers from 1 to 100. And he turns to leave, and Gauss raises his hand, and it's 5,050. Okay. Well, how did he do it? That's the question I want to leave you with for now.